Hello guys, this video is going to be about the physical quantity which is called the linear momentum. This quantity is symbolized by the letter P. This quantity is the multiplication of the mass of the object with its velocity. So this quantity is a vector quantity. Now, through this formula, we can see that the more mass and the more velocity within the object, the more momentum the object possesses. So as m increases and as the velocity increases, the momentum of the object also increases. Now, if we have masses that are having the same velocities, the one which has the higher mass, so we can say that this object is or this object is said to have the higher momentum. So this quantity is a linearly proportional, directly proportional with mass and the velocity vector. Now, why linear momentum? This physical quantity studies many actions or many actions that are happening in our daily life. For example, a car accident, a recoil of a handgun, a recoil of a cannon, a recoil of a rifle, billiard balls, Newton's game, and many stuff. This physical quantity studies two special cases, which are collisions and explosions. Collisions is when objects are hitting each other. So this object A and this object B are heading head to head in each other. Then this case is called collision. Explosion is the case when we have a cannon and a shell after firing the shell. And also we can take this example. If you have two blocks are stretched or are fixed with a string, and between them a spring. So when string is cut, the two blocks are getting away from each other. Then this case is called collisions, and this case is called explosions. Now, why linear momentum is here? Okay, as we said, the linear momentum studies two special cases, which are collisions and explosions, while Newton's second law couldn't, because Newton's second law studies the sigma f external. But here in these two cases, the internal forces are much bigger than that of the external one. So the external forces in these two cases are negligible. So here it comes the big one, which is the linear momentum, which solves these two cases. So as we said, during these two cases, the internal forces between the two blocks is much bigger than that of the external one. And also here, the internal force is much bigger than the external one. So during collisions and explosions, the internal forces are much bigger than that of the external one. So that's why Newton's second law is not applicable to study these two cases. Now, in my previous videos, I discussed some information about the energy isolated system, which is a system that doesn't exchange energy with its surrounding. In this video, now I want to talk about the mechanically isolated system, which is a system that the net external forces are zero. Now let's get deep in the momentum. As we said before, that the momentum studies some cases that linear momentum justifies the recoil back of the cannons, justifies the recoil back of the handgun, justifies the recoil of the two cars after accident. So Now we are going deep in the linear momentum to justify these facts. Now, if we take a system composed of a cannon and its shell, so this is the cannon, and this is the shell in its side, and this is the cannon C, and this is its shell. So if we want to specify the forces acting on the system, because this system is at rest, so the forces acting on it are the normal reaction of the whole system plus the weight of the whole system. But since the system is at rest, therefore the net external forces acting on the system are zero, because the normal reaction and the weight are having same magnitude but opposite directions. Now, so this system is mechanically isolated. So, because the system is a mechanical isolated system, and we have explosion, so during explosion, we can say that P is conserved. What does that mean? This means that the linear momentum total initially, which means the total linear momentum before collision is equal to the linear momentum after collision. So if we get back here, we have P cannon plus P of the shell initially is equal to P prime of the cannon plus P prime of the shell after collision. This is equal to, first of all, okay, MC VC of the cannon initially plus M shell, the velocity of the shell initially, is equal to mass of the cannon multiplied by the PC prime plus M of the shell multiplied by the velocity of the shell after the explosion. But as we've said before, that the whole system was at rest, so therefore the velocity of the cannon was zero and the velocity of the shell was zero. So these are tends to zero. So we end up in mass of the cannon V prime of the cannon plus ms vs prime. So therefore, if we take this term before the equal term here, we get that minus mc vc prime is equal to, let me clarify it well. So mc vc prime is equals to ms vs prime. So the negative sign here reveals that the two objects, so therefore the two objects which are the cannon and the shell are heading with opposite directions. So this negative sign justifies the fact that the cannon recoils back after the explosion. So in this case we can see that the cannon is heading to the left and the shell is heading to the right. So this sign reveals the fact that the cannon recoils back after the collision. So this is V S prime and this is V cannon prime. But also I want to say that the velocity of the shell is much bigger than the velocity of the cannon. And in my next video I'm going to talk about the elastic collision and the momentum.